Okay, so in this tutorial I want to show you how to solve this Harvard University equation. Okay, this is a tricky one because you are given a quartic equation. Then you have to find the value of x. Okay, so if it was a quadratic equation, it would have been easy. If it was a cubic, it would have been much easier. Okay, but now we have a quartic equation. We have the highest exponent, which is 4. Okay, so I want to show you a few tricks that you can use to solve this kind of equation. Okay, so you have x to the 4th. Then we have minus 72x. Okay, so there must be a trick to this equation. Okay, so the thing that we need to do, we have negative 17, so you have to try and write negative 17 as a difference of 2 squares. Okay, so now even though negative 17 is the same as 20 minus 37, but because 20 is not a square, because why I say 20 is not a perfect square, because when you take the square root of 20, you will not get something which is an integer, you get something which is in a decimal form. Okay, so the square root of 20 is 4.47. Because of this decimal, then 20 is not a perfect square. Okay, and also 37 is not a perfect square. So we can write negative 17 as 64 minus 81. Okay, because why I say 64 and 81? Okay, because 64, when you take the square root of 64, it gives you an inside, it gives you 8. Okay, so 64 is a perfect square. Then when you take the square root of 81, it's also a perfect square, so it gives you positive 9 in this case. So we can write negative 17. So the trick is to write negative 17 as a difference of 2 squares, 64 minus 81. Okay, so now instead of writing negative 17, I write 64 minus 81, and this is equal to 0. Okay, in this case, so now the expression is still the same, because when you say 64 minus 81, you go back to negative 17. Okay, then now you have to transpose the negative terms, so you have x to the 4th, then we leave positive 64 on the left hand side because it's still positive. Then you transpose negative 72, x becomes positive, transpose 81, it becomes positive 81. Okay, now we have an edge in this case. Okay, so we have x to the 4th plus 64, then we have 72x plus 81. So in this case, so let's try and complete the square. Okay, but before we can complete a square, we are only used to completing a square when we have something which is a quadratic equation. Let me make an example. We have something like this one: x squared minus 2x, say plus, let me say maybe in this case you have plus 5. Okay, then in this case you might want to complete a square if you want to solve this equation. Okay, so here's how you complete a square. You take the quotient of the middle term. Okay, so it's negative 2 in this case, but there's no need to consider the sign, so you take this 2 divided by 2, then this will give you 1. Okay, then you have to square this 1, then you get 1. Okay, in this case, then now you write this thing as x squared minus 2x. So instead of writing 5, you have to write your new term, you have to add your new term, so I have to add positive 1, then this thing becomes a square. Okay, x squared plus 2x plus 1 becomes a square, same as x. It can be written as x minus 1, that's 1 all squared. Then now you can add your 5. Okay, so you add your positive 5, then you have to subtract this 1 that you added. Okay, because it was not present in the original equation. Okay, so I added 1, then I have to subtract this 1. Okay, to keep the value of the equation the same, okay, as the one I had before. So this is how I wanted to show you how you can complete a square. Okay, so now when you complete a square, you normally get your third term, this case, but we have an issue. Okay, the equation that we have is a quartic equation, it's not a quadratic equation, because we have x to the 4th. Okay, so you can see you are used to completing a square when we have a quadratic equation. Okay, which means we need to think of this. So we need to think of this expression as a quadratic expression. Okay, now, so x to the 4th, you can write it as x squared all squared. Okay, now because we have the square, then this thing is the same as a quadratic equation. Okay, so you have x squared raised to the power of 2. So I have x squared raised to the power of 2 plus 64. So the only thing that I'm missing Okay, so I'm missing the middle term in this case. I'm missing the middle term, the term which would be the coefficient of x squared. Okay, the term which would be the coefficient of x squared. Okay. So you have to recall how we are used to completing a square. Okay, so in order to get the last term when we are completing a square, you take the coefficient of the middle term, you divide it by 2, then you square it. Okay, which means now we have to reverse this process. Okay, Okay, so instead of squaring sine, which means we have to take the square root of 64. So when you take the square root of 64, this will give you 8. Okay, then you need to remember, if I was completing a square, I would have taken, so if I was completing a square, this is how you get 64. Okay, this is how you get 64, which is your last term when you're completing a square. Okay, you take the coefficient of the middle term, you divide it by 2. Okay, so now you have a over 2, then you square this thing, so it becomes a squared. So it becomes a squared over 4. Okay, so imagine this thing is equal to 64. Okay, so it's equal to 64, then so it's a squared over 4 is equal to 64. Then you have to solve for a in this case. Okay, this will give you 16. Okay, otherwise you can try and reverse the process of completing a square. Okay, when you complete a square, you take the coefficient of the middle term, you divide it by 2, then you square it. Okay, which means now when you are reversing this process, instead of squaring this term, we have to take the square root. Okay, then instead of dividing by 2, you have to multiply by 2. So you take the square root of 64, you get 8, then you take this 8, you multiply it by 2. Okay, because the opposite of dividing is multiplying, and the opposite of squaring is taking a square root. Okay, that's how you get 16. Okay, so there are 2 ways. Okay, so which means our middle term, the quotient of the middle term is 16. Okay, so now it's x to the 4th plus the middle term as a quotient, which is 16. Okay, so we take up this expression as a quadratic equation. So we have x squared raised to the power of 2. Okay, if we had x in the place of x squared. Okay, if we had x squared, not x squared all squared. Okay, if we had x, this would have been 16x, but now we have x squared, which is squared, so now it's 16x squared instead of 16x plus 64 is equal to 72x plus 81. Okay, so now we added 16x squared to the left hand side, which means we need to also add it on the right hand side. Okay, so it's either you subtract it, you add it, then you subtract it, or you add it on both sides. Okay, so there are two ways of maintaining the equality of these two sides. So it's either we add 16x squared to the side, then we subtract it, or we add it on both sides. Okay, so I want to add it on both sides, so it's 16x squared. Okay, so now once you complete a square, then this side becomes a square in this case. So x to the 4th plus 16x squared plus 64 can be written as one. Okay, it can be written as one term. Okay, or maybe two terms all squared. Okay, which means you can open your bracket. Okay, then this thing can be written as x squared so you have x squared, then you need to take the square root of this. Take the square root of the constant term, which is 64. Square root of 64 is 8, so it's x squared plus 8 all squared is equal to then 72x plus 81 plus 16x squared. This can be written as, take the square root of 16x squared. The square root of 16 will give you 4. Square root of x will give you x. Then you take the square root of the constant term, the square root of 81 is positive 9. Okay, so now here's what we have. We have x squared plus 8 all squared, then we have is equal to 4x plus 9 all squared. So you have both your sides squared, so you can cancel the square by taking the square root. Okay, and now once you have the exponent equal, you can just equate the bases. Okay, you can think of x squared plus 8 because they are raised to the exponent, so these are just bases. So yeah, you equate your bases. Okay, so you take x squared plus 8 equate it to 4x plus 9. Okay, because they are raised to the same exponent. Okay, if you think of this thing as an exponential equation, again now we have to transpose all terms to the left hand side. So it's 8 minus 9, that will give you minus 1 equals to 0. So now you have a quadratic equation in this case. Okay, or the other option, okay, you have many solutions in this case. You have x squared plus 8 is equal to 4x plus 9. Okay, so here's how you can think of this thing. So it's either x squared plus 8 is equal to 4x plus 9. Okay, so when I have negative a all squared, this will be the same as a squared. Okay, which means there are two possibilities in this case. It's either x squared plus 8 and 4x plus 9, they are both positive. Okay, they are both positive, or one of the, or either x squared plus 8 is negative and 4x plus 9 is positive, or either x squared plus 8 is positive and 4x plus 9 is negative, because it doesn't matter whether you square a negative number or you square a positive number. If you square, you will get something which is positive. Okay, in both cases. Okay, so the first case, when we say x squared plus 8 is equal to 4x plus 9, so we imagine the left hand side to be positive and the right hand side to be positive. Okay, they will give us the same result. Okay, so now it means we need to consider the second case. Okay, when one side is positive and the other side is negative, it doesn't matter which side you pick as being negative. Okay, but we'll pick the right hand side. Okay, so the other solution is when you have x squared plus 8. Instead of having it equal to 4x plus 9, then you have to negate 4x plus 9. Okay, multiply it by negative. Okay, so it's negative 4x minus 9. Okay, then you transpose, you have x squared. Okay, transpose positive 4x, that will give you negative 4x, that will give you positive 4x. Then you transpose negative 9, that will give you 8 plus positive 9, which will give you positive 17. It's equal to 0. Okay, so you have two quadratic equations now. Okay, we have two quadratic equations. Then we can find the solutions. Okay, start with this one. So you have, so instead of you factorize or you use a quadratic formula. Okay, so my p is negative 4. Okay, then my a in this case is 1, and your c is negative 1 over 2a. Okay, so the first solution in this case, so x is equal to 2 plus root 5. Then you have your second solution. So the second solution is 2 minus root 5. Okay, so now we have to find the solution of this quadratic equation. So it's negative b, and my b is negative, my b is 4, plus b squared is 4 squared minus 4 ac. So a is 1 into c is 17. 17 over 2a. Okay, this one does not have a solution on the real number plane. Okay, so now, which means we have complex solutions in this case. Okay, so you have 4 squared minus 4 times 17. This is our discriminant. 4 squared is b squared minus 4ac. So you have 4 squared minus 4, and my a is 1 times c, which is 17. Okay, the discriminant is negative in this case. This is why we have no solution. Okay, which means, okay, its x is equal to negative b is negative 4 plus or minus the square root of its discriminant is negative 52 over 2. Okay, so negative 4 divided by 2, that will give you negative 2 plus or minus, then square root of negative 52 is same as 52i. Okay, 52i divided by 2. Okay, so it's negative 2 plus or minus 18i. Okay, so these are our solutions to that quartic equation. Okay, that's how you solve this question.